Good morning, everybody. Welcome to Kubernetes on Edge Day. I hope you have enjoyed all the awesome talks in the morning. I personally have learned so much from all of them. And we're going to talk about event processing on the edge. My name is Wang. I'm a software engineer working for Intuit. I'm also an open source community contributor, mainly working on Argo project community and the Numaflow project community. Since we got the last-minute confirmation on the slot, my coworker, Harsha, wasn't able to get enough time to work on his paperwork for travel. So I'm going to be the only one standing on the stage. Here's today's agenda. We're going to start with a brief introduction about who we are and what we do. And then we're going to talk about event processing on the edge, talking about the challenges and the difficulties. And then we're going to discuss our solution, an open source project named Numaflow, followed by a demo. And then in the end, if time permits, we're going to take Q&A. A little bit about Intuit, my employer. So Intuit is a US-based global fintech company. It's famous for its flagship products like TurboTax, Credit Karma, QuickBooks, and MailChimp. And here's our operational scale. We have 100 million customers using our TurboTax to do tax return every year, which get $107 billion involved. And we have 18 million US workers get paid by our QuickBooks, etc. Intuit is also a large open source community player. As many of you know, Intuit is creator of Argo, which is one of the most popular CNCF projects. We also open source a lot of other projects. The one we're going to talk about today, Numaflow, is one of them. And we also got 2 times CNCF End User Award in 2019 and 2022. Now let's move on to talk about event processing on Edge. Starting with the event-driven architecture. For anyone who is not very familiar, what is event-driven architecture? At a very high level, everything is synchronous. Everything is event or message-based. So we are all very familiar with the REST paradigm. You get a request, you send a response, and then you are done. But for events, it's a little bit more complicated. It starts with the event broker. People use Kafka, Pulsar, or any other pub subsystem. And if there's something happens or something interesting, you publish a message. If anyone who is interested in that message, you can subscribe to this message. And once you receive the message, you do some processing. You either say, all right, I'm done, or you can do something else. Say you publish another message to your downstream, could be another data store or another pub system, so that get the message propagated all the way through the system. And anyone who is interested knows what's happening, what's going on in the system, and can get things processed quickly and scalably. Right? So this is a very high-level introduction about event-driven architecture. Now let's look at some real-world example using event-driven architecture, especially on the edge. Assume you run a retail store. You want to do some automation for your inventory. So you're probably going to install some sensors on the shelf to see if the inventory level. If the inventory level is low, you're going to send some message to your edge device, and the edge will trigger some alert. Or maybe you're doing something smarter. You're going to place an order automatically, right? So think about the whole end-to-end process. Most of the things happen on the edge. It's event-driven. Some other examples. This is a real example that our open source community users are using Numaflow to process. They're doing predictive maintenance. So they're using some sensors to detect the device health by checking the temperature and the vibration levels. If the temperature is too high or vibration is too much, they're going to do some crazy calculation, data processing, and then to see if it's over the limit. And then maybe they're going to put in the safety protocol or initiating some maintenance. Some other examples using event-driven architecture on the edge device, smart traffic, right? So the left turn traffic light will never be green if there's no if there's no car on the left turn lane, right? Or if you do not push a button on the pedestrian, you'll never get a chance to cross the street. Smart surveillance. So all the cameras today have motion detection. Once the motion is detected, you're going to do some, recording or facial recognition, things like that. All of these are event-driven architecture running on the edge. Now let's look at the challenges and difficulties to run event-driven processing on the edge. So first of all, there are many different kind of event sources. So the events on the edge devices come from different sensors, different hardwares. So you need to get very familiar with those kind of protocols to integrate with them, right? So that's the first challenge. Second challenge, if you are doing some advanced or real-time data processing with the events you detected, and there's some language, there's some, so usually in a cloud-based architecture, you're going to do this kind of real-time data processing by using tools like Spark Streams or Flink. But on edge device, it's very difficult to do that. Right? And then language constraints. To do this kind of complex data processing, usually people use language like Java or JDK-based applications to do it. Flink, Spark Stream, they are all JVM-based. You either write Java application or Scala application to do this kind of complication. But on edge device, it's pretty hard. And lastly, we all know on edge devices, the resources are very limited. The CPU memory is not much. So, for example, you want to run complex data processing, there's no way to run Flink on edge device to do it. I ever saw someone on YouTube saying, get Flink installed on edge device, but I don't know if anyone ever succeeded doing that. I don't know how much resource going to use. So those are the challenges for event processing on the edge. And now let's see our solutions to address these challenges. Numaflow. Numaflow is an open source project we're working on. It's a Kubernetes native platform used to run event processing or complex streaming data processing. And our design philosophy is to get event processing or complex streaming data processing just like running serverless applications. Everyone knows Lambda from AWS. You don't need to worry about the infrastructure, just write your code and get the things processed, right? That's our design philosophy for Numaflow. So it's a Kubernetes platform, so it's going to be very lightweight and very easy to use. As long as you have a Kubernetes cluster, no matter it's a cloud-based Kubernetes cluster like EKS or GKE, or any lightweight cluster like Kine or K3S, you can use Numaflow to do event processing or stream data processing. As long as you know some basic Kubernetes operation, you can use Numaflow to process events or do streaming data processing, just like running a simple Kubernetes deployment. And we decoupled the processing logic from the source and destination. You just write your code once, can be used anywhere, plug and play. And you can use whatever language you want to use to write your data processing logic. So we make it as a language agnostic platform. And lastly, we make it scalable, reliable, and secure. So we provide out-of-the-box autoscaling. It could be autoscaling from 0 to n based on traffic and load. If there's no traffic, we'll autoscale it down to 0. That makes it cost efficient. In Numaflow, we have two different kinds of abstractions for event processing and stream data processing. For simple event processing, since we are a Kubernetes native project, we use Kubernetes CRD to abstract the workload over there. We named it as monovertex. So here on this diagram, you can consider this box as a monovertex. It's nothing but consists of multiple different pods. And we autoscale this pods based on traffic. And within each pod, there are multiple containers running over there. There's a source container which is used to read data from the data source. And you can have another container called transformer to write your own data processing logic. And separately, there's a sync container used to forward process data to some other data sync or doing some other operations. And if you look at the monoverse spec, it looks like this. So there's a source where you can define a container. Similarly, for transformer and sync, you have some other containers to do it. And we provide SDKs in different language for you to easily write processing logic in those containers. And we have Java, Python, Golang, and Rust support. Technically, you can use any language to do it. We are using gRPC over Unix domain socket to do the communication between those containers within one pod. So technically, any language is supported. And for complex streaming data processing, we have another different terminology named the pipeline. So a pipeline consists of multiple different vertices. This is the pipeline. This is a pipeline with like one source, two sinks, and two UDFs. Each box represents a vertex. A vertex is nothing but a set of paths. We autoscale each vertex independently based on traffic and load and back pressure. So it provides exactly one symmetrics. And here the source is used to ingest data from data source. And you can use either our inbuilt source to transmit data from Kafka or any other popular data source, or you write your own data processing logic with the user-defined source. Sync, similarly, you can write your own user-defined sync or inbuilt sync. And for UDF, stands for user-defined functions. Here we support a map reduce out of the box, which means you can either write a map UDF or a reduce UDF. And we support group by windows, fixed window, sliding window, and session window. So we can do things like group by some sort of keys every, let's say, 10 minutes, fixed window, or every 2 minutes with the 10 minutes window, sliding window, things like that. So if you look at the sample spec of a pipeline, it's something like this. Within the spec, there are two major sections. One is called vertices, where you define the vertices. Here in this example, you have there's an in, which is used to ingest data from a Kafka topic. And then you have an enrich step, which is a map function, and it's followed by aggregation. And then in the end, there's an output function, which writes to the Kafka. Then you have edge, define the relation for the vertices. And quickly look into the code running in the container. So this is the sample code for a map function. If you look at the function signature, the most important thing is something called data. And the data, if you look at the function in there, you don't see anything related to your upstream or data source. The platform will make sure all the data coming from data source or your downstream will be forwarded to the function, and then you only need to write data processing logic here. And after processing the message, your data, you're going to return a list of messages. And you're not seeing any downstream. As you return the downstream message, the platform makes sure the data will be right to the sinks. And now let's go to a demo. So I'm going to run a stream data processing pipeline on my laptop in a K3S cluster. This is actually a couple of our open source community users are using on their edge devices. So what am I doing on this K3S cluster? I have a complex data processing pipeline which has 4 vertices, and I have an in, which is a source, which is going to use to ingest some data, and I use the HTTP source here, and so I'm going to have a script running in the backend to post some data to this HTTP source to simulate the data source, right? And then I have a map UDF, which is used to give some tag to this incoming data. Here, the incoming data is some sort of integers, so I'm going to give even or odd, those kind of keys in this map UDF. And then I'm going to do an aggregation in the follow-up compute sum of vertex. It will do a sum for those inputting data. And if you look at the spec, it's doing every 5 minutes doing a sum, right? And then in the end, it's going to write to the sink. It's the sink right here is a log sink. So if we look at the sink, So you're going to see every several seconds, you're going to see some output here. For even keys, the sum is 168, and odd keys is 63, something like that. So I'm running a script in the backend to send some random data to the source. So this is something running on my local laptop, K3s class. You can run this anywhere as long as the edge device supports K3s cluster, right? Or any other lightweight Kubernetes cluster. Now I'm going to show you some real example running into the production. This is a lightweight mono-vertex to do simple event processing. And here you can see there's 11 pods around this for the transactions, and this is a throughput like 4K per second. And a complex example like this. This is a pipeline to power Intuit application knowledge detection, and then it's kind of crazy topology for this pipeline. And it's used to do things like, inference, to do anomaly detection, to do inference, and then have training in the same pipeline, and if read in different languages, writing to different things. Okay. And coming back to the slides. And let's do a quick summary about Numaflow. It's a serverless platform running scalable, reliable, event-driven applications or stream processing platform. It's Kubernetes native, which means it's not only something running in Kubernetes, but also use Kubernetes native feature to build the platform. It's very lightweight, can be used either on the edge or on-prem. And it's a language agnostic platform. We have different language support, reading SDK to help you write your own user-defined function, either in sources or things. It's scalable and cost-efficient, auto-scale from 0 to n. So it's capable of running on edge with a low resource footprint, right? And these are open source community users. I want to highlight two of them. One is called B-Cubed. It's a organization in the U.S. which it's a vendor for U.S. Defense Department, and they are using Numaflow to do signal processing on their edge devices. Actually, their edge device has no internet access. That's kind of interesting. The other one is called Boomer Groups. I think this is a company based in Europe. They're also, that's the one I mentioned in the example that they're using Numaflow to do temperature detection, those kind of to detect the health status of their devices. And we also have NTT, which is Nippon Telegraph and Telecom from Japan. And we have another session tomorrow afternoon at 1:30, and then they're gonna showcase how to use Numaflow to do AI machine learning to achieve accelerator training. It's going to be in the solution showcase room. Yeah, I think that's all for my presentation. And if you are interested in Numaflow, you want to bring it to Edge, and here is our GitHub repository. And there's a QR code. If you are interested in, just scan it, and then you're going to find GitHub repository over there. And if you have any question, you can join our community or a Slack channel. You can find those links from there. And I'm happy to take questions. No question? All right. Thank you.